welcome back to the Backyard Professor Math videos. We're going to continue on graphing various equations and showing how to do this. We want to become familiar because we want to get rid of that lost feeling. When we're told graph y equals 2x plus 2 and you go, huh? What does that mean? We want to know what to do. We want to know what that means. We want to be able to not feel lost and know exactly what to do. In equations like this, what we want to do, y has been solved. Y equals 2 times some variable plus 2. So we find numbers for this x variable, and then we'll automatically know what y is. And that'll give us our pair of coordinate points, and then we can graph it. Isn't that cool how that works? So the first thing you want to do is build yourself a chart of x, y, and xy coordinates. You want to always build your chart. Take the time, take the moment to make this chart. It makes your life infinitely easier. And now, all it's a matter of doing is plug and chug with numbers. Let's pick -1. If x is -1, then y equals 2 times -1. We're plugging and chugging our number into x plus 2. And that equals -2 plus 2, which is 0. So when x is -1, y is 0, and there's our first coordinate pair, -1 and 0. Isn't that cool how that works? It's really interesting because we can pick any number that we want for x. Keep the numbers small, keep the numbers below 4 or -4, and then that way you can graph them real easy. We don't want to get complex equations right now. We don't want to get complex numbers. This can get very involved. You may have to have 50 coordinate points in order to properly answer whatever problem you're working on. But for right now, we just want to learn how to do it, what to do, etc., right? So when x is 0, then that means y equals 2 times 0, we're plugging in 0 to x, the variable here, plus 2. This is 0 plus 2. So y equals 0 plus 2, which is 2, and there's our second coordinate pair of points, is 0 and 2. When we choose the number 2 for x, that means y equals 2 times 2 plus 2. This is 4 plus 2. So y is going to equal 6. So when x is 2, y is 6. And there's our third coordinate point, 2 and 6. So let's graph this. Now that we have our coordinate points, we can graph it. Get graph paper. It's much, much more accurate. You want to try to be as accurate with your graphs as you can. That's why you need rulers and graph paper. It gives you the even spacing anyway, and you can be more accurate in plotting other points. So we have a -1 and 0. We always start with x. This is x. Y is up and down. X is across. We always begin with the x number first on the x-axis. So we have -1 and 0. We come over here, -1 and 0. It's right there on the axis. If y is 0, it's not positive 1, 2, 3, 4. It's not -1, 2, 3, 4. It stays right on that axis. Then we choose 0 for x and 2 for y. When x is 0, we start right here. We don't go to the right, 1, 2, 3, or 4, and we don't go to the left, -1, 2, 3, or 4, because it starts at 0, so we stay on this part of the line, and then we go up 2, so O2. So 0 and 2 is on the y-axis. X is 0, and then you go up 2. Then when x is 2, y is 6, so we come over 2 on x. It's positive 2, so we go to positive side, the right side, and then we go up 6, which is going to be up here somewhere. We can see the line that the dots are forming, can't we? There's our graph. right there. There's how to do our graph with these 3 coordinate points. If someone comes along and says, but 2 and 3 are also part of this solution. See, these coordinate points represent solutions to this equation. These are true solutions as we've worked out to this equation. Now we've graphed it. If someone says, well, you missed 2 and 3, we now have our graph. We can say, well, we come over 2 and up 3. Nope, it's not on the line. It's out here. So that's not going to be a solution to this equation. If we do a negative 4 and 2, we come over here, negative 4, 1, 2, 3, 4, and up 2, we can also see that that coordinate pair is not a solution to this graph. Only the coordinate pairs that land on this line, and this line goes forever. If that was a point, that would be a solution. If we had a point here, that would be a solution. It looks like it's about, what's that, 1, that's about 1 1/4, and 1, 2, 3, 4. Something like that. But that's how we do these graphs and solve the equations so that we can chart those graphs. This is a great method. This is one of the most ingenious things René Descartes, the French mathematician and philosopher, ever did for math. He welded together geometry and algebra with this Cartesian coordinate system. Spectacular breakthrough for us. Hallelujah. Okay, so now we're going to graph this equation, y equals negative half x, minus 2. So we want to graph this. Again, we build a chart of x values, of y values. We plug in x values so that we can solve for y, and then we find that those two values together are our xy coordinates so that we can put them on a graph. This is extremely helpful to do. So let's say we chose a value of 2 for x. That means y equals negative 1/2 times 2. We plug in our 2 for the x here, minus 2. 2, this is going to be, this ends up being negative 2 over 2, which just simply equals negative 1 minus 2, which is a plus minus 2. So negative 1 plus negative 2 is negative 3. You see how I got that? So that's the value for y. When x is 2, y is negative 3, and there's our first coordinate pair. 2 and negative 3. That's kind of nice how that works. Now if we choose 0 for x, this tells us that y equals negative 1/2 times, we're plugging in 0 for x, 0, subtract 2. So this is 0 minus 2, which is simply negative 2. So when x is 0, y is negative 2, and there's our second coordinate point, 0 and negative 2. Nice how that works, isn't it? Now when we choose negative 2 for x, this says y equals negative 1/2 times negative 2 minus 2. Negative 1/2 times negative 2 is negative 2 over negative 2, which simply equals 1. Minus 2 equals negative 1. Sorry, I didn't mean to get that all muddled up there, but I'm just trying to find y because I need to graph it down here. So our next coordinate point is when x is negative 2, y is negative 1. Now we have 3 pair of coordinate points that we can graph on the Cartesian coordinate system. We draw our y-axis, our x-axis. You should always draw x first, sorry. I did a very unorthodox, incorrect thing there. I'm sure the math world's going to slay me for it. Now we can graph our coordinate points. 2 and negative 3, x. You always begin with x. X is always listed first. I'm not going to tire of repeating that because later on when we get into a little bit more complex equations and formulas that we're going to want to memorize, we're going to have to make sure we pick the correct values of x and the correct values of y in order to solve some formulas later on. Very important. That's why I'm emphasizing it now. Just get used to this. X is the priority. So we have 2 and negative 3. So we come over here, positive 2x, positive 2. Y is going to be a negative 3. We know negative is below the x-axis, so we come down here negative 3, and there's the first coordinate point. Hey, even the cows agreed with me. He said, yes, that's the correct coordinate point. Then we have 0 and negative 2. We start at 0. We're not going to go to the right, because that's positive territory. We're not going to go to the left, because that's negative territory. We stay on 0 for x. And we go down 2 for negative 2. So it's on the y-axis. And then our third coordinate point is negative 2 and negative 1. We come over negative 2 and down negative 1. You can see the line there, can't you? You connect the dots. Ooh, it's not going to be a very straight line. There's our graph right there. That's how to do this. By plugging in values of x in the variable, we solve for y. Pick easy values. You noticed I picked values of 2 and negative 2 because what that does is I have a fraction, a negative fraction here. It eliminates the fraction in my y answer. For instance, if I would have picked 3, let's just do 3 real quick. Let's say I'm doing 3, then that means y equals negative 1/2 times 3 minus 2. Here, this becomes negative 3/2 minus 2. You can see that now you're going to have to, it's a subtraction, so you're going to have to get the common denominator. 2 is 2 over 1. You need that to go to 2, so you multiply this by 2 over 2, which means this is negative 4 over 2, and then you can subtract negative 3/2 minus 4. You see, you have the double negative there, so this is going to simply be 1/2. But you're still left with a fraction. It's okay if you want to do a ton of fractions like that. This is great practice, but any number you pick for x, when you solve in this equation, will be a point on this line, even if it's way out there up into the hundreds or thousands or millions. There's an infinite number of solutions, and you can find any solution pair you want through the calculation. Isn't that cool? I think that's really helpful. So there's another example of how we're doing graphs. Okay, now I'm going to introduce you to the equation y equals mx plus b. We'll work with this equation a lot in algebra. This is the graph of y equals mx plus b as a sample graph. What does this equation tell us? It's been solved for y. Y is isolated on this side. So y equals m times the variable x plus b. M is just a number. This is just a number, whatever number we calculate it to be, and so is this b. This b is just a number. We need to understand that. But what do these numbers represent? As a brief introduction, m is going to be the slope of the line. And the slope of the line is simply how steep the line is in the graph. Is it like this, or is it really steep like that? That's the number m will tell us what the slope is. The b is what they call the y-intercept. I'm just going to initial it int. The y-intercept. What this says is, this number is where the line crosses the y-axis. Here, the y-intercept is going to be right there on y. In this line, the y-intercept is right there. We will manipulate this and use this till the cows moo and come home like they're doing with me right now. So, when you have an equation, y equals 3x plus 2. You can see that this is this form of equation. And in order to solve a lot of linear equations, we want to get them into this form. You can see this is very similar. This is y, corresponds to that, equals mx. The 3 corresponds to the m, which is just a number, like I say, and then the variable x, plus b, which is just another number. In this instance, the number is 2. So this is the form of linear equations that some linear equations take, and it's very important to recognize that b is the y-intercept, right there, this number. So in this graph, whatever the graph is, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, whatever graph is, we know that 3x plus 2 at the point of 2, right here on the y-axis, 1, 2, we're going to have the line going through that. That's what the y-intercept says. That's where that line is going to cross in that. So the y-intercept means that the x number is 0. You see that? So the coordinate point of the y-intercept in that equation is going to be 0 and 2. X is 0, y is 2. That's why the line can cross at 2. This is very important for us to be able to solve later equations. If we're told y equals 1/2 x minus 4, we know the 1/2 is going to be the slope. That corresponds to m here. Y equals mx. Well, here y equals 1/2 x minus 4. It can be y equals mx plus b, y equals mx minus b. The form is what's important here. We know this number here is the y, the number on the y-axis where the line's going to cross. So in a graph, whatever way this numbers go, whatever way this chart's going for now, we know that the y-intercept is going to be 0 and -4. X stays to 0. You don't go to the right on x. If you did, you'd be off the y -4. It wouldn't be 0. You stay on the y-axis and drop down 4. That's the y-intercept. The yint, as I call it. These are going to be critical to help us to understand how to graph and solve equations. Believe it or not, we're going to be able to use this to solve all kinds of equations. What if we're told that y equals -x plus 1? And you say, well, wait a sec, there's no, this is the same form, y equals mx plus b, but there's no m here. Ah, but there is. Remember, the -x implies that there's a -1x plus 1. So the slope is going to be -1 here, the m. The steepness of the line is going to be -1. The y-intercept is right there. X has to be 0 when there's a y-intercept, because it's always going to be on the y-axis. So this is 0 and 1 is going to be your y-intercept. And on a chart, it's going to be right there, 1 notch above the x-axis because it's positive, 0 and 1. This one is 0 and -4. This one is 0 and +2. That's why it's 2 above the x-axis. It's 2 points up because that's where the line crosses the y-axis. This is called the y-intercept. It's a very, very important concept for helping us solve many, many equations coming up that we'll practice. This is cool stuff. I love this stuff. Now math gets picturesque.